Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is AQA November 2023, Paper 1, Higher Tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1, work out the lowest common multiple or LCM of 20 and 25. There's a few different ways of doing this, but probably the quickest is just to do an exhaustive search for this one. They're not that big, these numbers. Won't take me long to find one in common, I don't think. So multiples of 20 are 20, 40, 60, 80, 100, 120 and so on. And 25 is 25, 50, 75, 100. Oh look, 100. That's on both lists. So that is our lowest common multiple there then, isn't it? So LCM is 100. Question 2, work out the size of the exterior angle of a regular hexagon. Okay, for regular polygons, then the size of one exterior angle is going to be equal to 360 divided by the number of sides. Useful formula to know. So here, it's a hexagon, and a hexagon has got 6 sides, isn't it? So n is 6. So each exterior angle then is going to be 360 divided by 6, which is 60. So that is my exterior angle there then. Each one is 60. Question 3, A is 2, 0, and B is 0 minus 4. Work out the midpoint of AB. Okay. So to work out a midpoint of 2 points, what we need to do is average out their 2 coordinates. So the x coordinates here are 2 and 0. So averaging those out, 2 plus 0 over 2, that comes to 1, doesn't it? 2 plus 0 is 2, divided by 2 is 1. And if I do the same thing with the y coordinates are 0 and minus 4. So 0 plus negative 4 over 2. That's negative 4 divided by 2, it's just minus 2, isn't it? So that's 1 minus 2. 1 minus 2. Okay. Question 4, simplify a plus 3a divided by a. Okay, so we need to be following the order operations, or we can think of BIDMAS as a way of remembering that order. So here I've got division and I've got addition. So division trumps addition, doesn't it? Okay, in the BIDMAS order. So I'm going to have to do that division first. 3a divided by a. Well, 3a divided by a, those a's are going to cancel each other off, isn't it? And it's just going to be 3. And so I've then got a plus 3, which is just a plus 3, because I can't add those together any more than they already are. Okay, so that's just a plus 3. Question 5, work out the value of a squared times a divided by a to the power 9 divided by a to the power 5. Okay, so BIDMAS again, brackets first, that trumps everything. So I'm going to do the things inside the bracket first. So those two there, look. So 8 squared times 8 Two numbers with the same base multiplied. I'm going to add the indices, aren't I? So a to the power of 2 times a to the power of what? It's just 1, isn't it? 2 plus 1 is 3. So that's going to give me 8 cubed. Divided by a to the power of 9 divided by a to the power of 5. So 9 subtract 5 is 4. So it's a to the power of 3 divided by a to the power of 4. So again, I've got two numbers with the same base. So I'm going to subtract the indices this time. So 3 subtract 4. That's going to be 8 to the minus 1 then, isn't it? Okay. What does 8 to the minus 1 mean? A negative index means the reciprocal of. So that is 1 over 8 to the positive 1, or just 1 over 8. Okay, so we need to write that down as a decimal. It's a handy one to remember, 1/8. It's just 0.125, isn't it? That's what I remember. I remember half is 0.5 or 50. Half that, it's going to get 25, and then half it again, you're getting 12.5, aren't you? Or it's decimal 0.125. Okay, so that's the answer. 0.125. Question 6. A music company releases 10 albums. The scatter graph shows for each album the number of downloads on the first day and the number of CDs sold on the first day. A line of best fit has been drawn on the scatter graph. Yes, it has. So we've got no number of downloads along the bottom and number of CDs up the side. They've already got a line of best fit on here. It looks like it's positive correlation. What are the questions going to be? Question A. The scatter graph shows positive correlation. Yes, it does. Describe the relationship between the number of downloads and the number of CDs sold. Okay, so if you're asked about correlation, it's either positive or negative, no correlation. If you're asked about the relationship, you have to say, well, as one increases, does the other one increase or decrease? Here they increase, so I'm going to say, as the number of downloads increases, so does the number of CDs sold. Part B says the company earns £2.50 for each download and £3 for each CD sold. The company releases another album. On the first day, it has 9,000 downloads. Estimate the total amount the company earns from the downloads and the CDs of the albums that day. Okay, so we're going to use the number of downloads to estimate first the number of CDs sold. And we're going to do that by reading up from 9,000 on the scatter graph and across. Okay, so finding 9,000 on my scale, and on the bottom there, look, I'm just going to draw a line up until I hit the line of best fit. Then I'm going to change directions and I'm going to draw across until I hit the other axes over here, look. Okay, and then what does that say? That comes out to be, it's like two little squares up from 5,000. 5 little squares spans 1,000, so each little square must be 1,000 divided by 5. It's 200. So 2 squares is going to be 5,400 then, isn't it? That's what it's going to represent. So estimate of CDs sold equals 5,400 from the graph. Okay, so now I've got 9,000 downloads and 5,400 CDs sold. I can then work out my estimate of the amount that has been earned. So, sale of CDs, what's that then? It's going to be 5,400 times the cost of each CD, which is times 3, isn't it? So what's that? 0, 0, 4 3s are 12. So 2 carry 1, 5 3s are 15, plus 1 is 16. So that's going to be £16,200 for the CDs. And then downloads, that's going to be 9,000 times by £2.50 then, isn't it? Okay, so what's that then? So 0, 0, 0, 9 5s are 45. And then add a 0, and 0, 0, 0, 9 2s are 18. So adding that up, got 0, 0, 0, 5, 2, 2 then, haven't I? Now I had one digit appearing after the decimal point here, because I just wrote it as 2.5 to spare myself some extra zeros. So I'm going to have like one digit in from there is going to be where my decimal point lies. So that's actually 22,500, isn't it? Okay, so then total earnings going to be those two added together then, isn't it? It's going to be 16,200 plus 22,500. What does that come to? 16 and 22 is 32, 38. 38,700 then, isn't it? 38,700 pounds. Not bad. Question 7. 70% of a number is 350. Work out 120% of the number. Okay. So if 70% is 350, we want to build up to, what, 100%, 120%, which is 50% more. So I think I need to find 50% and add it on there, don't I? So if 70% is 350, then what's 10%? 10% would be a seventh of that. 350 divided by 7, that's going to be 50. So then 50% is going to be 5 lots of 50. That's 250. Okay, so then 120%, then that's going to be my 70% plus my 50%. That gives me 120%. So adding those two together then, 350 and 250, what's that? That's 350 plus 50 is 400, plus 200 is 600, so that's 600. So that's my answer, 600. Question 8. In the diagram, all the lengths are in centimetres. And we're told the two shapes have equal areas. Work out the ratio of k to m. Okay. So we've got a triangle which has got height of 12 and base of k. So its area is going to be half base times height, isn't it? So that's going to be a half of k times 12. Half of 12 is 6. That's going to give me 6k. So the area of the triangle is 6k. What have we got for the other shape over here then? I think what I'm going to do is I'm going to divide it like that, and that seems to make sense. So I've got area 1 and I've got area 2. Area 1 is a rectangle, so it's just length times width, which is 2 times k, which is 2k. And then area 2 is also a rectangle, so it's still length times width. That's going to be 3 times m, which is 3m. And then, so then the combined area is those two things added together, then, isn't it? So it's like 2k plus 3m. All right? So we've got that, but we also know that the two shapes have equal areas. So that means we can equate those two things. We can say, well, 6k is equal to 2k plus 3m. And if that's the case, if I take 2k away from both sides, then I know that 4k is equal to 3m. And then I've got to flip that into a ratio. Okay? Now you've got to take care with ratios because the numbers always appear on the opposite sides as they do in an equation. So if I've got 4k equals 3m, then the ratio of k to m, the 3 and the 4 are going to appear on opposite sides. It's going to be 3 to 4. I know that, and I can just write it down. But if I rearrange this and I said k was 3m over 4, just dividing both sides by 4, you can see that k is 3/4 of m. So if you let m equal 4, then k would be 3/4 of 4, wouldn't it? And then you can see that they're going to cancel and leave you k was 3. So if k is 3/4 of m, if m is 4, then k is 3. So the ratio then of k to m is 3 to 4, look like that. Okay, so that's kind of why it is how it is. But I just kind of remember, if I've got an equation in terms of two things, then the coefficients in the equation, if I rewrite it as a ratio, always appear on the opposite side. Okay, so just a handy rule of thumb to remember. So the ratio is 3 to 4. Question 9, here's the graph of y equals a half x squared minus 6x plus 12. Use your graph to estimate the solution of half x squared minus 6x plus 12 is equal to 0. Okay, so notice we've got the same thing here. Here it's equal to y, here it's equal to 0. Okay, so if I want to find the points that satisfy that solution, we're talking about when y is equal to 0, and the line when y is equal to 0 is actually the x-axis. So what I'm looking for is where this graph crosses through the x-axis, which is here and here, Okay, so there's two solutions. It's where it crosses through that x-axis. Now that first one is smack bang in the middle between 0 and 5. So that means that x is equal to 2.5 for that one. And then the second one, that looks like it's halfway between the fourth and the fifth little square from 5 to 10, isn't it? So each one, there's 5 divisions between 5 and 10, so each one's worth 1. So that's going to be like 9.5 then, isn't it? So x is 9.5 there. So x is 2.5 or x is 9.5. Question 10. Shape A is a circle with radius root 17 over 2 centimeters, and shape B is a sector of a circle with radius 5 centimeters. Which shape has the greater area? Is it A or B? You must show your working. Okay. Well, area of a circle is just pi r squared, isn't it? Cherry, pie, delicious, apple, pies are 2. We want the area one. Area equals pi r squared. Okay, and then here the radius is root 17 over 2. So that's pi times root 17 divided by 2 squared. When you square root, you just get your number back. So that's going to be 17 over 4. So that's 17 pi over 4 then. I'm going to get there, 17 pi over 4, because don't forget you need to square the 2 as well as the root 17 on the top. This 2 here is distributive. It distributes to both the numbers inside your bracket like that. So it's 17 pi over 4 for the area of shape A. Let's have a look at shape B. So shape B is a sector, which is a fraction of a circle. So its area is going to be whatever that fraction is, times by the area formula of a circle, pi r squared. Okay, now this particular sector has got an angle of 60 there. So it's 3/60ths of a sector. Okay, which is the same thing as 1/6, isn't it? Because 60 goes into 366 times. Here, the radius is 5, so it's going to be 1/6 of pi times 5 squared. 5 squared is 25, so that's 25 pi over 6. Okay, so which one is bigger? I now need to work out is 25 over 6 is bigger than 17 over 4 then. Okay, which is the bigger fraction? Okay. So, could we find a common denominator for those? 4 and 6 both go into 12, don't they? So if I double up the denominator and the numerator for this one, I'm going to get 50 pi over 12. And if I do the same thing over here, this time I have to multiply it by a factor of 3 then, don't I? 3 17s is 51. That's 51 pi over 12. So you can see here then that 51 is bigger than 50. Okay, so shape A is greater. Okay, question 11, factorize x squared plus 2x minus 24. I'm going to start with the number on the end, this 24. I'm going to think about factor pairs of 24 because I know that quadratics factorize into brackets like this. If I've got an x squared at the front, I'm going to have an x and an x to multiply together to give me my x squared. And then the numbers on here and here need to be a factor pair of 24 then, don't they? So they need to multiply together to give me 24, or minus 24 actually. So what are the factor pairs of 24? Factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now we're aiming for 2 in the middle. We need to get a 2 in the middle. And remember, one of these has to be positive and one has to be negative. So I'm actually looking for the pair of factors which, when you add them together, is going to give you 2, bearing in mind that one is positive and one is negative. And I think it's going to be this one here then, isn't it? So if I make 4 the negative one, minus 4 and plus 6, look, then that is going to give me 2. So I'm going to say x minus 4, x plus 6 is my factorized solution then. So that's it. X minus 4, x plus 6. 12a, right? 2 times 10 to the 3 is an ordinary number. 2 ways you can do this. You can just think about the magnitude of that number. 10 to the 3 is 1,000. So this is going to be a number in the thousands. So it's going to be 2,000s. The other way you can think of it is 10 to the 3 is a 2 with 3 zeros then. Okay, so either way it's 2000. 12b, simplify the ratio 2 times 10 to the 3 to 5 times 10 to the minus 1. Give your answer in the form of n to 1. Okay, so we already did the first bit, didn't we? So 2 times 10 to the 3 is the answer from part A. So I already know that that's 2000. That's easy squeezy. And what's 5 times 10 to the minus 1? That's a very small number, isn't it, when you've got negative indices? I usually think about this as whatever the number is there is the number of zeros I need to write down before I write the mantissa down. So here I'm going to have to write 1 0 down. So actually it's 0.5. Okay, so it's 0.5 is 5 times 10 to the minus 1. Now if I want to turn that into a ratio where that part there is 1, what I really need to do there is double it then, don't I? If I times that by 2, half times 2 is 1. So doing the same this side, times it by 2, I'm going to get 4,000. Then that is my final ratio, then it's 4,000 to 1. Okay. Question 13. Here is an identity in x. I've got 5 lots of 2x plus d is identical to cx plus 30. Okay, work out the values of c and d. Now, whilst this may look like an equation, that identity symbol in the middle means we have to kind of handle these slightly differently. What you don't want to be doing with an identity is moving things from one side to the other. What you want to do is you want to make each side look more like each other so you can more directly compare what you've got. Okay? So on the left side I've got factors, and on the right hand side I've got a sum of terms. I think the easiest thing to do is going to multiply out this bracket so I can get a sum of terms on both sides. Okay, so if I take the left hand side and I multiply out that bracket, I'm going to get 10x plus 5d, and I know that's identical to cx plus 30. So now I can more directly compare these. So I've got two terms in x. Now if these things are identical, then the coefficient of x there must be equal to the coefficient of x here. So I'm going to say comparing coefficients of x. So coefficient just means the number in front of x. Then I've got 10 is equal to c. Okay, so c is 10. And then comparing constants, which is the numbers on the end, I've got 5d is equal to 30. Well, you might think, well, 5d's got, why is d a constant? Well, it's not an x, and generally x is the variable, and if it's a different letter, they tend to be constants, and here is a constant I need to find. Okay, so here I know that 5d is equal to 30, so then d is equal to 6. Question 14. Cora is revising for two subjects, history and French. The time she spends revising is in the ratio of history to French in the ratio of 7 to 2. The time she spends revising for history is 20 hours more than the time for French. Work out the total time she spends revising. I'm going to just quickly model this using bar modeling. So if I just show those kind of 7 hours here, look, for history. Okay, well, 7 parts, I guess. I've got 7 parts versus French, which is 2 parts. Okay, so history is 5 parts here, look, and French is those 2 parts there. And we know that she spent 20 hours more revising for history. So that difference between the 2 bars then, this kind of extra bit on the end here, that has to be 20 hours then, isn't it? So that's 20 hours. Okay. So we know that the blue bit is 20 hours, and it matches up with 5 of the chunks from history, isn't it? So the 5 shares there are equivalent to 20 hours. So if I've got 5 sections and they add up to 20, that means that each section must be worth 4 then, isn't it? 4, 8, 12, 16, 20. Okay, and because all the shares are the same size, that means that also must be 4, and that must be 4, and that must be 4, and that must be 4. Okay, so what is the total time she spends revising? Well, then I've got 7 lots of 4 there, haven't I? So she spent 7 times 4, that's 28 hours revising history. And French, she did 2 lots of 4, so that's 8 hours. So altogether then 28 and 8 adds up to 36 hours. Okay, so she did 36 hours altogether. Question 15. A race was run in 2019 and 2020. The box plot shows information about finishing times in 2019. 15a says, in 2019, what was the fastest time? Now, on a box plot, this is your lowest, and this is your highest, isn't it? But in terms of time, is your fastest time the biggest time, or is your fastest time the smallest time? Now, I remember when my students were doing this as a mock, a lot of them wrote 29 here, or 29, is it 29? 29.5. Anyway, the upper limit. That's not the one you want here, is it? You want the lower one, because you don't win a race with the longest time, you win a race with the shortest time. So it's actually this value here that we want, which is what we've got, 10 little divisions between 15 and 20. That means that 2 little divisions must be 1 unit. So that's going to be 16 minutes then, isn't it? So that's 16 minutes is the shortest, not 29 and a half. Okay. Part B says the table shows information about finishing times in 2020. So this table here is the 2020 times, and the box plot was 2019, wasn't it? Okay. So use the data to comment on each of the following statements. On average, the times were faster in 2019 than in 2020. So comparing the fastest times, you want to be thinking about the median, the average time, and compare those. That's the easiest way to do that. So the median is Q2, that little line in the middle. In 2019, it was here, look, it was at 22.5. Okay, so the median was 22.5 in 2019. In 2020, it was 24. Okay, so I can say yes, on average, the times were faster in 2019. So what am I going to say about this? This is true as median time in 2019 was 22.5 minutes, and in 2020 it was 24 minutes. And it says times were equally consistent in 2019 and 2020. So to comment on consistency, we need a measure of dispersion. Okay, so on the box plot, we could work out range, which is the highest minus the lowest value, but we can also work out interquartile range because we've got the upper quartile and the lower quartile. I just noticed I wrote Q2 on that, did I? Meant to be Q3 anyway. So for 2019, interquartile range is Q3 minus Q1. That's going to give me an interquartile range of, what's that? It's 26 minus 20 has an interquartile range of 6. And then for 2022, interquartile range is the upper quartile, Q3 minus Q1 again. The upper quartile is 27 minutes. And the lower quartile is 21 minutes, giving you 6. So yeah, that's true as well. This is also true as the interquartile range is equal to 6 in 2019, and interquartile range is equal to 6 in 2020. Okay. Question 16. The Venn diagram shows information about 80 people who visited an online shop. So the universal set is equal to 80 people. T is the people who bought trainers. H is the people who bought hoodies. And you can see some of those have been given algebraically, so we're going to have to find out what that X is in a minute. One person is chosen at random, work out the probability that they bought a hoodie. Okay? So, yeah, the first thing we're going to do is have to work out that x. Now, we know that the universal set is 80, so that means all 4 regions of this Venn diagram need to add together to 80, because that's the number of people in the universal set. So that means if I take the numbers in the 4 regions, 15 and 8 and x and 2x, and add them up, I'm going to get 80, which is the number of elements in the universal set. Okay, so I've got 2 types of thing here. I've got numbers in x and I've got numbers that are numbers. Okay, so add in the numbering numbers together, 15 and 8, that makes 23. Add in the x's together, that's going to give me 3x, and I know that's equal to 80. So taking 23 away from both sides, that's going to be, what, 57. So 3x is 57. Luckily that divides by 3. X is then 19. Okay, so if that x is 19, then that means there are 19 people in there, and 2 lots of 19 out of here. What's that? 38. Okay, so now we're in a position that we can actually answer the question. Work out the probability that they bought a hoodie. So bought a hoodie is anyone inside this circle here. Then that's bought a hoodie, isn't it? Okay, of which there were 8 in there and 19 in there. So altogether there's 8 plus 19 then, isn't it? So the probability of hoodie is going to be 8 plus 19 over how many people are there altogether? Well, there are 80, aren't they? So I'm picking from 80. So 8 plus 19 is 27. It's going to be 27 over 80. That's my answer, 27 over 80. Oh, I just wrote all that in the wrong box. Silly me. Let's just budge that up there. I can do that with my magic pen. Right, next one says one person who bought trainers is chosen at random. Work out the probability they bought a hoodie. Okay, so this time we're not picking from the universal set. We're picking from the people who brought trainers. Okay, so from within this circle here. This is what we call conditional probability. So we want the probability that they bought a hoodie given that they bought trainers. That's the notation for it. That line there means given that. So what's the probability that they bought a hoodie given that they bought trainers? Well, we know that of the people who bought trainers, 8 people bought a hoodie. And how many people did buy trainers? That's going to be 15 plus 8. Okay, so 15 plus 8 is 23. So that probability then is going to be 8 over 23. Question 17. X and Y are integers. Work out the largest possible value of Y. Okay, so we've got 2 inequalities here. They're not in their simplest forms though, are they? So I'm just going to simplify these first. That first one, if I just divide everything by 4, so I've got 3 parts to this inequality. I need to divide each 3 parts by 4. So 8 divided by 4 is 2. That's less than 4x divided by 4, which is x, which is less than or equal to 20 divided by 4, which is 5. Okay? And then I've got y minus 3x is less than 12. So what does that tell me then? So y minus 3x is less than 12. I think because I've got minus 3x, which is not very nice, I'm going to add 3x to both sides first, just to make the 3x positive. Okay, I don't like having negative things, especially on inequalities. So adding 3x to both sides, I'm going to get y is less than 12 plus 3x. Okay, so it's minus on one side. I want to move it over, it becomes positive. Okay, then I might just leave it like that actually. So y is less than 12 plus 3x. What's the largest possible value of y? Well, I guess the largest possible value of x is going to allow the largest possible value of y then, isn't it? Okay, so if I think about, you know, like x has to lie between 2 and 5, so it can be 2 and it can be 5 because it's less than or equal to. Okay, so it can be 2 or 3 or 4 or 5. It can be any of those numbers there. Okay, but if I want to get y as big as it can be, I want this number here to be as big as it can be. So I'm going to pick the 5 as the largest possible value. So y then is going to be less than 12 plus 3 lots of 5 then. 3 lots of 5 is 15, so then y is going to have to be strictly less than 12 plus 15. So y is going to be less than 27. So it can't be equal to 27. It's an integer, so the biggest integer that is less than 27 is y is equal to 26 then. Okay, is the largest value. 26. Question 18a. P and Q are points. P, which is the point -3, -2, is mapped to Q by a rotation about 1, 0 through 90 degrees clockwise. Q is mapped back to P by a single transformation. Complete these two single transformations that each map Q back to P. Now you might want to do this with a bit of tracing paper. Another way of doing it is kind of with night moves. If you have a look at the distance between the center of rotation and P, it's like 2 units down and 4 across. If I rotate that 90 degrees clockwise, it's going to be 2 units to the left and 4 units up. It's going to end up here. This is going to be the point Q up here then. Okay, so then if I want to take Q back to P again, I'm just going to have to do the same rotation but in the opposite direction, aren't I? So if I rotate it, a rotation of 90 degrees anti-clockwise, about the same point, which is 1, 0. Okay, that should take me back to where I started from. Okay. Now the wording on this one had me puzzled for a bit, but I guess what they mean by the second part, translation. So by translation, they mean, well, what translation would take Q back to P again? Okay, so how would I get from Q back to P again using a translation? It would be a translation using vector. Now vectors are two numbers, one above the other. We need an x number, okay, and we need a y number. And so x is how far it is between those points in the direction of x. So if I'm going from Q back to P, I'm going 2 to the left, which is in the opposite direction of x. So that's going to be -2. And I'm going to be doing 1, 2, 3, 4, 5, 6 down, aren't I? Which is in the opposite direction of y. Y is going up and we're going down. So that's going to be -2, -6 would take me back to P, won't it? Okay. Question 18b. Point A, which is at coordinate 7, 4, and the line y equals x are shown on the grid. Yes, they are. B and C are points on the grid, each having positive integer coordinates. BAC is a right angled triangle. When BAC is reflected in the line y equals x, BC, the side BC is invariant. Okay, so if the side BC is invariant in a reflection, the only points on the reflection that are invariant are the ones that lie on the mirror line. So that means that B and C both lie on the mirror line, and if it's a right angled triangle, then we're talking about B and C being these 2 points here then, I guess. So let's just make our triangle like this. So doesn't really matter which way around B and C go, does it? No. So that could be B, that could be C, or the other way around, doesn't really matter. So if I reflected that in the line, I'm going to end up with a triangle here, aren't I? Okay. So you'll see that B and C don't move, and the line BC doesn't move. It stays on the mirror line. Okay. So yes, so BC, B is 4, 4, and C is going to be 7, 7 then, isn't it? Or the other way around. So 4, 4, and 7, 7. Question 19. When converted to a fraction, 0.7 reoccurring equals 7/9. Work out 0.4 reoccurring plus 0.07 reoccurring. Give your answer as a fraction. Well, I guess if I know that 0.7 reoccurring is 7/9, then what would 0.07 reoccurring be? Okay, that's like 10 times smaller than what I've got there. So if I just multiplied the denominator by 10, made it 7/90, then that's going to be 10 times smaller, isn't it? Because I've made the denominator 10 times bigger, so my fraction will be 10 times smaller than it was, and so 0.07 reoccurring would become 0.0. So 0.7 reoccurring would become 0.07 recurring. That seems fine to me. So all I really need to do then is to work out what fraction this bit is then, 0.4 reoccurring. So I'm going to let x be 0.4444 and so on. And then 10x is going to be 10 times as much. That's going to be 4.4444 and so on. Okay, and then if I subtract those from each other, so subtracting those, okay, then you can see all these 4's cancel each other out, leaving me with 10x minus x is equal to 4 minus 0. In other words, 9x equals 4. So then x then is going to be 4/9. Okay? So what am I doing here? I'm doing 0.4 reoccurring plus 0.07 reoccurring. And I know that 0.4 is 4/9. And I know that 0.07 reoccurring is 7/90. And I want to add those together. Just need to change the denominator on the first one into 40 over 90. So they have a common denominator there. And then go ahead and add them then, can't I? So that's going to be 47 over 90 then as my final answer, 47 over 90. Question 20. X and Y are acute angles. I know that sine x equals root 3 over 2, and w equals 3x minus 2y, and tan y equals 1. Work out the value of cos w. You must show you're working. Okay. Well, this is all about exact trigonometric values, isn't it? So I'm going to have to know my exact trigonometric values. Okay, so currently I'm using this handy way of remembering them. All right, sine and cos next to an enormous root symbol. And I've got the angle 0, 30, 45, 60 and 90, which corresponds with the numbers 0, 1, 2, 3, 4 for sine, and 4, 3, 2, 1, 0 for cos, and that's all over 2. Okay, so the way this works is if you want the sine of an angle, you would look up the sine and the angle that you wanted, and then you'd pick the number out of the root. That would be your numerator, and then it'd be over 2, okay, which is going to be your denominator. Now I want one which is root 3 over 2. Where's my root 3 going to be? It's going to be this one here. Root 3 over 2 is the sine of 60. Okay, so the sine of 60 is the root 3 over 2. So that means if sine x equals root 3 over 2 there, and x is acute, then if sine x equals root 3 over 2, it implies that x equals 60 degrees. Okay, and I know that tan y equals 1. So the tangent of an angle is its sine value divided by its cosine value. The tan of an angle is equal to its sine numerator divided by its cosine numerator. So if I've got the tan of y is equal to 1, which numerators are going to cancel each other out and give me 1? It's going to be these two, isn't it? So it's the 2 and the 2 there. So if I divide root 2 by root 2, I'm going to get 1. So that is 45 then, isn't it? So tan y equals 1 implies that y must be equal to 45 degrees. Okay, so then w, which is 3x minus 2y then, is going to be 3 lots of 60 minus 2 lots of 45. Okay, which is 3 lots of 60 is 180 minus 2 lots of 45, which is 90. That's equal to 90. Okay, so if w is 90, then what's the cos of w? Cos w equals the cos of 90 then, and that's going to be what? Cosine 90. Well, that is cosine 90, is that 0? It's root 0 over 2, which is just 0. So the answer is big fat 0. Question 21. f of x equals x minus 9 over 8, and g of x equals 2x squared plus 9, and h of x equals 4x. We're asked to solve f to the minus 1 of x is equal to g of h of x. F to the minus 1 of x is the inverse function of f. So we need to find the inverse function of f, and g of h of x is the composite function where we take h of x and we feed it into g of x. So what fun. We're going to have to find those two things And then we're going to have to equate them and then see what that kind of boils down to. So I'm going to find the inverse function of f first. So starting, I'm going to replace f of x with y. So y equals x minus 9 over 8. So rearranging for x, that gives me 8y equals x minus 9, just multiplying through by 8, and then adding 9 to both sides, I'm going to get 8y plus 9 is equal to x. Okay, so then to turn that into an inverse function, I would just replace the x part with f to the minus 1 of x, and I replace the 8y plus 9. I'm just going to rewrite it, but I'm going to replace the y with an x. So because I introduced y to start with, and when we're using functions, we don't use y, so we use f to the minus 1 of x and f of x. So that's going to become 8x plus 9. Okay, so that's my inverse function. So that's part of the puzzle. So we worked out this bit here. So now we need to kind of work on this bit, g of h of x. Now, g of h of x is, you kind of work from the inside and you work out. So I'm going to start with the h of x because that's closest to the x, and I'm going to feed it into g. So I'm going to take the function h and I'm going to feed it into g. So this bit here, look, 4x, which is the h of x, I'm going to then feed in to where you see x written in g of x, which is there, look. So I'm going to replace that x in there with h of x, which is 4x. Okay, so that becomes g of h of x is going to be equal to 2 lots of, but rather than having x squared, I'm going to replace x with 4x. So it's going to be 2 lots of 4x squared plus 9. Just replacing the x in g of x with 4x, which is h of x. Okay, so then working that out, what's that then? Removing the bracket, squaring that up. Don't forget I need to square both parts. I need to square the 4 and the x. So that's going to give me 2 lots of 16x squared plus 9, which is the same thing as 32x squared plus 9. Okay, so now I've got g of x is equal to 32x squared plus 9, and I've got f of minus 1 of x, which is 8x plus 9. So then I can equate these two things. I can say, well then, f to the minus 1 of x equals g of h of x. So f to the minus 1 of x is 8x plus 9, and that's going to be equal to 32x squared plus 9. So I can see straight away those 9s cancel. Then just bringing everything to one side, I'm going to get 32x squared minus 8x equals 0. Okay, I just collected things on the right and then flipped it around so I can make a, something with 32x squared being the positive term. Okay, so you can see both those sides are going to divide by 8. So let's divide them by 8 first to make it a little bit more simple. So dividing both sides, everything by 8. So 8 goes into 32 4 times. That's the same as 4x squared minus x equals 0. And then I can factorize x out. So I'm going to get x lots of 4x minus 1 is equal to 0. And then so what values of x does that work for? That works for x equal to 0 or x equals, what, a quarter? Okay, there's my two solutions there. X equals 0, x is equal to a quarter. Question 22. Here is a cyclic quadrilateral. I've got a to b to c is in the ratio of 9 to 5 to 3. Work out the size of angle D. Okay. So I know that a to b to c are in the ratio of 9 to 5 to 3. And I also know that in a cyclic quadrilateral, opposite angles add up to 180. So if I've got a opposite c, so a is opposite c, look, a is opposite c, then that part and that part must be equivalent to, those shares got to be worth 180 between them. Okay, so I've got 9 shares and 3 shares, that adds up to 12 shares. So 12 shares is equivalent to 180 degrees then, isn't it? So 12's into 180, that goes 15 times then, so that means that 1 share is 15. Okay, because 15 twelves is 180. Okay, so that means if each share is worth 15, so if I take this ratio of A to B to C and I scale it up by a factor of 15, I should get the angles of those three things then. So taking that and scale it up by a factor of 15. 9 times 15 is going to be 1945. That's 135. And then 5 times 15, what's that? 75. And then 3 times 15 is 45. Okay, so that means angle A is 135, angle B is 75, and angle C must be 45. Okay, so we can see already that these two add up to 180 because that's what we used to find them. But then also these two are going to have to add up to 180 as well, aren't they? Okay, and now I know that B is 75, then D is going to be equal to 180 minus 75 then, isn't it? So what's that? That's 105 degrees. D equals 105 degrees. Question 23. Work out 7 over root 2 times root 3 over root 10. Give your answer in the form of x root 15 over y, where x and y are integers. Okay. So I think what I'm going to do here is I'm going to combine all these roots if I can. So when you've got two fractions and you want to combine them, top versus top, bottom times bottom is going to give you what you're going to get. So here I'm going to get 7 times root 3 is just 7 root 3. Root 2 times root 10, I can say that's the same thing as root of 2 times 10, which is the root of 20, isn't it? So that becomes the root of 20 there. Okay, and then so to then rationalize this, because I've got root 20 on the bottom, it's not very nice, is it? So to make it look a little bit more pretty, we can times top and bottom by the root of 20, like that. Okay, so then top times top, bottom times bottom again. So denominator is easy. Root 20 times root 20 is just 20. And I've got 7 root 3 times root 20. That's the same thing then as 7 root 3 times 20 is root 60. So I've got 7 root 60 over 20. Surely 60 must have some square factors, mustn't it? So what are the square numbers? 1, 4, 9, 16, 25, 36, 49. So which one of those are factors of 60? So the biggest number I can see on that list, which is a factor of 60, is 4, isn't it? Because 4 goes into 60. 4 goes into 60 15 times. So I can rewrite that as 7 root 4 times 15 over 20. And if I then square root 4, I'm going to get 2. Combining the 2 with the 7 is going to give me 14. So that's 14 root 15 over 20. Now that's in the right form, isn't it? Because I've got x root 15 over y up there. I've got 14 root 15 over 20 here. So x is 14, y is 20. All kind of works out. Looks great. Let's move on. Question 4. Line A is perpendicular to line B. The gradient of line A is -2. Work out the gradient of line B. Okay, well, if I've got two gradients that are perpendicular, then you can say two ways of thinking like that. The one is the negative reciprocal of the other. Either m1, m2 is equal to -1. That's one way of writing it down. Or you can say that m1 equals -1 over m2. Okay, either of those are the same. Well, they're just variants of the same thing, aren't they? So if I know the gradient of A is -2, then the gradient of B is going to be the negative reciprocal of that. So it's going to be, flip it over, change the sign. I'm going to get negative, so it's going to become positive. It's 2. I'm going to flip it over. It's going to become a half. Question 25. The nth term of a geometric progression is Rn. The second term is 8 over 9. Work out the third term. Give your answer in the form c root 2 over d, where c and d are integers. Okay, so the nth term of a geometric progression is Rn. Normally we use a lots of Rn to the power of -1. That's what I normally use, but they're telling us here it's Rn, so that's what we're going to use. So I'm not going to use that one today. I'm going to use Rn. So if un equals r to the power of n, then, and I know that the second term is 8/9, then I know that u2 which is going to be r to the power 2 is equal to 8 over 9. Okay, so if r squared is 8 over 9, then r is going to be the root of those two numbers. It's going to be the root of 8 over the root of 9, which is, well, the bottom part becomes 3. And 8, square root of 8, that's, well, that's 2 root 2, isn't it, in its neatest form, because 8 is 4 times 2, and 4 square roots to 2. So that's 8. Root 8 is 2 root 2, and root 9 is 3. So it's 2 root 2 over 3. Okay, so that's our value of r. And then, so what we want is the third term, u3. So u3, which is r cubed, is going to be that thing cubed then, isn't it? It's going to be 2 root 2 over 3 cubed. What's that then? Well, 2 cubed, I'm going to have to cube everything here. Going to have to cube the 2, going to have to cube the root 2, and I'm going to have to cube the 3. Okay? So because powers or indices are distributive over multiplication and division, so yeah, everything gets raised to the power 3. So what's 2 to the power 3? That's just 8. So I'm going to get an 8 from that. What's root 2 to the power of 3? So that's going to be, well, root 2 is 2 to the half. If you times it by 3, I'm going to get 2 to the power of 3 over 2. So 2 to the power half raised to the power 3. I don't know what that is. I'm just going to write 3 over 2 for now. I'm going to come back to that in a minute. Okay, I'm just going to work out the rest and then think about that bit. So then 3 to the power 3, that's 27. So what's this 2 to the power of 3 over 2 then when it's at home? Well, that's going to be the square root of 2 cubed. And the square root of 2 cubed is 8, so it's going to be root 8 again, isn't it? So, and we know that root 8 is, so it's going to be 8 root 8 over 27, and we know that, well, we just did that earlier, that root 8 is 2 root 2, so that's the same thing as 8 times 2 root 2 over 27, which is the same thing as 16 root 2 over 27. And I believe that's going to be my answer. 16 root 2 over 27 then. Question 26a, work out the value of 5 1/16 to the power of 1/4. Ooh, mixed number. Don't want that. Let's rewrite that as a top-heavy fraction first. So what's 5 times 16? 5 16s are 80, plus 1 is 81. So that comes out to be 81 over 16 to the power of 1/4. Okay, so I need to find the fourth root of those two numbers. What powers of 4 do I know? Well, 1 to the power 4 is just 1. 2 to the power 4 is 2 times 2 times 2 times 2. 2, 4, 8, 16. So the fourth root of 16 is going to be 2. 3 to the power 4, 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is going to be 3. So that's just 3 over 2 then. That's my answer, 3 over 2. Part B says, write 49 to the power of m to the power of 2.5 as a power of 7 in terms of m. Okay, so I can see that 49 in the middle is 7 squared. So the first thing I'm going to do is replace that 49 with 7 squared. So I've got 7 squared raised to the power of m, and then that is raised to the power of 2.5. Got a bit of a power tower going on here. So you can just multiply all these things together, isn't it? Because when you've got an index of an index, you just multiply them. So I'm going to do 2 times m, and then whatever that is, I'm going to times by 2.5. So in other words, I just need to multiply those three things together. Okay, so I think I'm going to multiply the 2.5 by 2. That's going to give me 5. So this is just the same thing as 7 to the power of 5m. Okay, I think that's it. Yep, right. That as a power of 7 in terms of m. 7 to the power of 5m. Done. 7 to the power of 5m. 27. Write down the solution of x squared is less than 16. Now take care here. It's not just x is less than 4, because when you square root, you have two solutions, plus or minus. Much better in a situation like this to move everything to one side and factorize. That's the safest way. Don't just root. So x squared minus 16 is less than 0. So then that's what we call the difference of two squares. It factorizes into x plus 4, x minus 4 is less than 0. Okay, so what does that look like? As a parabola, I'm going to have two solutions, one at x is minus 4 and one at x is 4. We want when it's below the axis, when it's less than 0. So this curve is less than 0 while it's below the axis, and the values of which it's less than 0 are the values of x between minus 4 and 4. Okay, so this as an inequality is that x is greater than minus 4 and less than 4. Okay, so that's what my solution is. I really recommend you draw a sketch for these. Don't just try and work it out, otherwise they can be quite tricksy. Much clearer if you just draw the inequality parabola out and look at that. Okay, so x lies between minus 4 and 4. Don't lose the solution. Question 28. PQRS is a quadrilateral. PQ is not parallel to SR. X is a point on QR. Q to x to r is in the ratio of 2 to 3. And we're given that the vector q to x equals 2a plus 4b. Okay, well that's all very exciting. And we've got some more vectors drawn on the diagram that I haven't mentioned there. And we need to prove that PQRS is a trapezium. Okay, well a trapezium needs to have one pair of parallel sides, and they've already told us that PQ is not parallel to SR. So these two are not the parallel sides, they're not parallel. So what we need to do is show that these two are parallel, because we need to have one pair of parallel sides for it to be a trapezium. Yeah. So we need to show that those two sides are parallel. That means we need to work out what P to S is, because we already know what Q to X is, Q to R is. It's just going to be some multiple of Q to X. So I don't really need to find Q to R. I just know it's a multiple of Q to X, so it's going to be in the same direction as that. Okay, so really I need to just find P to S, compare it with Q to X, see that one is a multiple of the other, and then I'm done. Okay, so how can we do that then? What is the vector P to S? Vector P to S. How can I get from P to S along routes that I know about? Oh, well, I do need to know x to r because I need to get to S. So I'm going to go a bit of a circuitous route. I'm going to go, because I don't know the vector going straight from P to S, I'm going to have to go around routes that I do know about. I'm going to have to go this way, and then this way, and then back up to here, because I know about those routes. So I'm going to say P to S is the same thing as P to Q plus Q to R plus R to S. Okay? I'm going to go the pink route. Now, I know all of those. P to Q, we're going against the arrow there, so that's going to be minus 5a. Then, what's Q to R? Actually, I haven't found that yet, have I? Oops, I was meant to do that first. So let's work out what Q to R is and come back to that. What's Q to R? Well, I know that these are in a ratio of 2 to 3. So as a fraction then, so there are 5 parts altogether, of which Q to X is 2 parts. So that means that Q to X is 2/5 of Q to R then, isn't it? So if Q to X is 2/5 of Q to R, then Q to R is 5/2 of Q to X. Okay, do I need to write that down for you guys? So if I've got, probably I do. So yeah, I was thinking, well, if QX is 2/5 of Q to R, isn't it? Okay, that's probably an easy way for you to see it. Then if you multiply both sides by 5/2, then you get 5/2 of Q to X is equal to Q to R. Yeah, does that kind of make sense? So Q to R is 5/2 of Q to X, and Q to X is 2a plus 4b. So just multiplying through by 5/2. 2 divided by 2 is 1 times 5 is 5, so that's 5a. And 4b divided by 2 is 2b times 5 is 10b. So that's 5a plus 10b. Okay, so Q to R is 5a plus 10b. So 5, remember I was adding them up here, 5a plus 10b. Okay, and then R to S I know is a minus 8b plus a minus 8b. Okay, So what does all that become? So I've got minus 5a plus 5a. Those two are just going to cancel each other out. And I've got 10b minus 8b. That's 2b. And an a. So I've got a plus 2b. That's what that resolves to. So p to s is a plus 2b. Q to r was 5a plus 10b. Which I guess I can then factorize and say, well, if I factorize out a 5 out of that, that's equal to 5 lots of a plus 2b. Okay, so if q to r is 5 lots of a plus 2b, and we've just found that a plus 2b is p to s, we know that q to r is 5 lots of p to s then. Okay, in other words, QR is a multiple, a scalar multiple of PS. QR is a scalar multiple of P to S, and therefore QR and PS are parallel. Okay, because if two vectors, if one vector is a scalar multiple of the other, that means they're both going in the same direction, and therefore they both must be parallel. Okay, so that's enough. We found that QR is a multiple of P to S, and therefore we're all good. Yeah. Question 29. Here are the equations of three graphs: y equals sine x, y equals cos x, y equals tan x. Which statement is true? Y equals sine x passes through 180 minus 1, y equals cos x passes through 180 minus 1, y equals tan x passes through 180 minus 1. Well, it'd be helpful if I knew what these three graphs look like. Sine x is a sine curve. It starts at 0, 0. It reaches its zenith there at 90. It's back down to 0 at 180. It's at the lowest point at 270, and it's back up to 0 at 360. That's what it looks like. So does it pass through 180 minus 1? No, it passes through 180, 0. That's where it passed through the x-axis, or the x-axis again there, isn't it? So that one is definitely not true. Okay, y equals cos x. Does that pass through 180 minus 1? Well, cos, I mean, it starts off looking like sine, but it's slightly out of phase, isn't it? Because the tallest point of your sine curve is when x is 0. Okay, so it's 1 at 0, at 90 at 0, at 180 it's minus 1, and then at 270 it's 0 again, and then at 360 it's up to 1 again. So yes, this one is going to be minus 1 at 180, so that one is the one I'm going to tick. Okay, so I'm pretty sure that is the one. I'm just going to double check tan. So tan, what does tan look like? So tan looks like this. It's kind of like a curve, looks like that, and then it repeats every 180 degrees. Okay, so that's 0, 90, that's going to be 180, that's 270, and then I suppose I'm going to have a little wiggle there at 360 then, aren't I? For part B, it's the same question, but it's whether or not it passes through the point 271. So 270 on the sine curve, it's going to be actually at minus 1. It's down here, isn't it? At 270 on the cosine curve, it's at 0. At 270 on the tan curve, well, not actually there, is it? Because that's an asymptote at 270. So it doesn't actually pass through at 270. That's where it zips up to infinity. So actually none of them pass through 271. So I'm going to tick this last box here. Cheeky. Tricky question, that one. Yeah, so none of them do.
Mr. T, he's the best. Helps you ace every test. Maths worries now.